Everything that you've learned so far in Statistics 2 and Statistics 1 about distributions regarded random variables that were discrete in nature. What does this mean? This means that the values that the random values could take were specific. I mean, could be 1, 2, 3, etc. But then you have another type of random variables that do not have this restriction. They can take any value within a certain range. We are talking about continuous random variables. So these can take any value in a certain range, and their behavior is going to be completely different. The way to calculate probabilities is going to be different as well as compared to discrete random variables. You already have one specific distribution that you learned last year and that you used at the end of chapter 1 this year, and by year I mean qualifications, Statistics 1 and Statistics 2, which was the normal distribution. If you think of the normal distribution, you may remember that the random variable x can take any value within a certain range. It's impossible for you to calculate a probability that x is a specific value in the normal distribution, right? All you have to do is to calculate the probability using areas under the bell curve, if you remember. Well, you can expand what you've learned with that distribution, or generalize it to any continuous random variable, because now we are going to talk about probability density functions the same way that the normal distribution uses a probability density function. But now this can take any shape. The thing that you need to understand is that the probability density function is going to be a line that is contained within two values. And the probabilities are calculated via the areas between two specific values, right? So, as you've learned in Pure Math 1, let's say that you want to calculate for this random PDF the probability that x is in between values a and b. How do you calculate areas? Via integrals. So all you have to do, after you know the function that describes the behavior of this curve, is to integrate that function between points a and b, calculate it, and the value that you are going to obtain is going to correspond to that probability. As simple as that. How is the function defined in the first place? Well, it's defined between 2 points a and b, not this a and b, 2 points, if you prefer, c and d. And outside of these points, the probability for you to find any value x is going to be 0. So it's contained only on that. Actually, the function needs to be positive or equal to 0. Obviously, that's a probability density function, so this only makes sense in the positive side of f of x. And obviously, also, if you integrate the function with no limits of integration, that is, for all possible values of x, then the result is going to be 1. What does this mean? This means that the probability of x being something is 1.